let me talk a bit about asynchronicity. I shortened down the whole stuff, so will be just like a short overview. I will not go in too much details for that. So the idea is, if you already optimized your code and your kernels perform well, you maybe can get some overhead by overlapping different computational tasks, or maybe computations with data movements and so on. And there are different names for that. So in OpenACC, it's called streams. With OpenMP, we say we do data dependencies, but at the end, it's very similar to the so-called CUDA stream. So we have different tasks we want to schedule, or we want to process in parallel. So at the end, if we distribute our tasks on the GPU, we usually need a certain synchronization so that all tasks finished, and we can be sure that our distributed data will really not change before we may be moving it back to the CPU. So by default, the compiler will handle this synchronization. But you can also change for CCE, you can change this behavior by using this compiler flag -h ACC model, auto-sync from none to maybe kernels or all, and then the synchronization is done also on a different level. But you can also change the behavior manually with certain directives in your code. So for example, in OpenMP, you can add these no wait clause for kernels and updates, and then telling the compiler that it should not do this synchronization automatically. And you can introduce the synchronization by yourself by using the task rate and barrier directives to really then ensure that you have synchronization. Another way to do that is the so-called depend clause in OpenMP. And I will show you in a second a nice example which describes it quite well, I would say. And this really controls the order of the different tasks to define, and therewith you can really enables the compiler to create a certain overlap of that. And the syntax for this depend clause is that you just name depend, and then you give a certain type, and then you always act on a variable, so a name, and the type can be in out or in out, which means if you have a dependency of in, which means that the previous task, which maybe has a dependency of out of the same variable, has to be finished first. If you previously have a dependency of in, out of the same variable, this also has to be finished. And the same is for out. So out has to be finished first before another task with the dependency in of the same variable can start. And in, out combines both. So these dependencies can then also easily defined to create a real tree of dependencies, and it should be mentioned that this dependency is really just for scheduling. It's not about moving your data or handling your data. It's really just defining dependencies on your data. So, simple example here. for OpenMP. So we have a pipeline. We define our data here with the alloc statement A and B. And then, for example, in the update clause, we say, okay, we have a dependency of out of A since we updated A, and then we define a new kernel here, which has then the dependency of A. So A has to be updated first before this kernel can be executed, and the next kernel just can start if A, if the first kernel finished. So we have a dependency out also here for the variable here, and in for the second kernel for this variable. And at the end, we can then also define the task rate that we imply the synchronization for that. So maybe a bit more complex example where I do not have any loops and stuff. I just define like kernels there. So I have dependency. So I have an out dependency of X here for the first kernel, in, out, also for X on the second kernel. But then I maybe have a third kernel, but there I act on different data. So I have an out of Y there. And then maybe I have a fourth kernel needing the results of both previous kernels, so X and Y. So I define dependencies of in, out for both variables there. And then maybe I have now two kernels then acting on each of the variable again. And so I can really build a huge tree of dependencies. And this kernel then here can nicely overlap and can be scheduled on the GPU together. So this is also quite nice to improve your code. So with these dependencies, as mentioned, you can make an overlap of the computation, but you can also be sure that that certain tasks go one after each other, and you have also you also should take care about the synchronization in between. So then coming to OpenACC, there it's similar. We use the async clause to do this kind of dependency handling. And we also have for synchronization then the wait directive. And we can again do that also with multiple streams, where we then can also define for the async clause different arguments. So again, like before different names. So here's a short example where we then have the async of J, and we do one kernel after each other, depending one on the previous one. And as in short visualization, we did that with the NVIDIA Visual Profiler. You then see you have your different kernels here, and they now can nicely overlap so that at the end you do not have large times in between, and you drastically reduce your runtime. So also there, a more complex example. I mean, it's quite similar than before. There you just have these async and a certain name, or tag or flag, or however you want to call that. And yeah, it was faster than expected. My last slide is, as we already mentioned, I think, also from my point of view, the deep copying is, especially for C and C++, the biggest issue. And here the elephant in the room. And yeah, as Markus mentioned, hopefully in OpenACC that will be implemented. OpenACC 3 will be implemented, excuse me. And I also hope, and that's as far as I know the plan, that in OpenMP 5.0, which is not clear when that will be released, also a real deep copy is implemented, but that's future. For Fortran, some of you are using Fortran, and using CSCE, so the Cray compiler, there's also a compiler flag, -h model deep copy, and then the compiler should do the deep copy for you. So that's the compiler implementation, which is not portable, so you cannot use it with other compilers. But if you could stay with CCE and have Fortran code, that would be one workaround to really have deep copy available. Questions?
If for some reasons I would like to have in the same code ACC directive that parallelize on the CPU and others in the same code that parallelize so on the GPU, is there a way of doing so?
You mean OpenMP directives, which parallelize on the CPU and OpenACC for the GPU?
Or one way would be that, but also just plain OpenMP doing both. Well, OpenMP has different directives.
Yeah. I mean, if you want,
OpenACC has the same directive.
Excuse me?
Right. So from what I understood, OpenACC has the same directive for both CPU parallelization and GPU. And so I would love to have both in the same code for whatever reasons.
You mean if you use this multi-core feature? As I understood, and please correct me if I'm wrong, if you specify this multi-core feature, you just use it on the CPU. You do not use them both.
Okay. You parallelize for one or for the other by specifying the target. So you generate code for one or the other by specifying the target, but you wouldn't be able to use parallelism on both platforms simultaneously at the same time. That's currently not implemented in OpenACC.
So with OpenMP, you practically can do that. So you have the OpenMP host parallelization, the OpenMP target parallelization. If you want to have your code really portable, so let it run on a pure CPU machine and on a CPU-GPU machine, then what you usually have to do is to do really compiler if-defs and then distinguishing at least between OpenMP target team distribute and OpenMP parallel do. And then, I mean, the data scoping is the same, so you could then do that region for both cases of your if statement. But yeah, that you have to distinguish. So far, the compiler cannot do that for you.
Yeah, you can essentially do the same. You can essentially do the same, like if you go down the route of using preprocessor if-defs to sort of select which directives you use. You can use an OpenMP parallelization level on the host on top of an OpenACC parallelization for the GPU. That's not a problem, that works. We've seen that in applications, and that actually you just go multi-threaded on the CPU, and then you have each CPU thread, for example, launch kernels into different streams or asynchronous queues and things like that. So that can be used very efficiently. And if you need to differentiate anyways with preprocessor, then it doesn't really matter what you're differentiating between. So that works there too.
You just have to be really careful about your data handling and which OpenMP tasks finished, and you know. Yeah.
I haven't said it's easy.
No. I agree. Just wanted to mention out that fact.
You would compile with OpenMP and OpenACC.
Yeah.
In that case.
Both Cray and PGI, that works.
Yeah, that works for both.
But not for GNU or Intel.
So far.
Intel doesn't support OpenACC, so that's your answer there. For GCC does support OpenMP and OpenACC, although their OpenACC is under development, and I don't know how the interoperability between the two is in GCC. I would have to look that up. But potentially that should work at some point as well, because they use both.
Can I come back a bit to your question? So, Marcus, couldn't you possibly use compiler pragmas? For example, you have an OpenACC region and you want this to be on this multi-core. Could you possibly, is there a pragma to pass the compiler and compile this next block of code with a specific option? It's like, I mean, in GCC you have pragma GCC and you can turn on and off optimization flags.
That's not implemented, no.
Okay, so it's either the whole code, I mean, either it goes on the multi-core or on the,
yeah.
Okay,
I'm
it's the
thinking
target.
you could mix it, like compile different source files in a different way and do it this way, but I would have to find it out.
Yes,
I'm not
that.
sure that works at any extent.
Ah, okay, 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 good, good.
More questions? Last chance.
The slides, if we pull them now, are they latest?
I have put the slides of yesterday, so today I will update. I've also put the solutions, so you will see the directory solutions, and today I will also push the slides of today, sometime in the day.
So will we have access to them for a couple of days once it's up?
Yes, I think so. But I think the accounts will be, so you won't be able to run as far as I know, because there will be no reservation.
But at least home
To get,
okay.
yes. Right, JT?
So for certain projects, you could also ask for, we have these so-called MPN, Marketing Partner Network Machine at Cray, and you could apply for an account there. I mean, we have, on these machines, so far we have no Pascal GPUs, but they are Kepler GPUs, so if you just are interested in GPU parallelization and want to test your code and look how it works out and so on. No, that's machines from Cray being located in US. So there's just Google for MPN Cray and you find a form where you simply describe what you want to do and then usually you get your account there.
Generally at CSCS you can apply for a development project, which are projects that, I mean, research projects that they do not require lots of resources and are meant for the users to develop and enable their codes for the GPUs. And you can find instructions on our website.
And if my project now is allowed on CPU partition, can I also ask to extend it to GPU?
No, that's a different thing. Is it a development project or a production project? No, production projects go through a different review process.
But it's already running.
On the CPU partition. Yeah. So, yeah, I mean, that's, if you want the production, you should apply for, you should have a code that is enabled for GPUs, and you should apply, and then you will be granted the GPU partition after a review process, which has two steps. One is technical review and then a scientific review. But development projects, because they don't require so much resources, I mean, the review process is anytime during the year and can be granted much more easier. So,
Will we still be able to email for support about porting our codes to you guys, or for assistance? Or just generally, if we're now going to go away and try and work on our codes, can we email you guys for support on that, or?
Yes.
We can, but you don't have to reply.
I don't know if you're working on. If you're working on bits daint, and you have a code there, then you can go through the help at CSCS. Now, if you don't have a project there and an account, of course you can just send us individually in email, and we're happy to help you.
Okay, great.
If you have a problem, if you have a problem with an OpenACC code, you can also post either on Stack Overflow. That's something where people get a lot of help. And for OpenACC, there's a Slack channel, OpenACC user group, where people also post questions and get help from people who have done a lot of GPU development or sometimes compiler engineers and so on. So it's also a fairly quick kind of turnaround to ask simple questions. I mean, you can't really post a 20,000 line source code there and ask for thorough analysis, but if you're struggling with some smaller problem, that's usually a very good way to get a quick answer.
If you have larger code, then consider the hackathons. Build up a team and apply for a hackathon. So it is really helpful. I mean, several teams go out with at least the first porting of their application or understanding their behavior, and they know what their next steps would be. So that's really helpful. So any more questions? Okay, so then I think we are finished. We've finished the workshop, and in time. So thank you all for your participation, and I hope you got something useful, and at least you have the foundation now to start playing around with OpenACC or OpenMP and GPU programming in general. So yeah, have a nice trip back or a nice day in Lugano, and see you.
Let me talk a bit about asynchronicity. I shortened down the whole stuff, so will be just like a short overview. I will not go in too much details for that. So the idea is, if you already optimized your code in your piece, but at the end, it's very similar to the so-called CUDA stream. So we have different tasks we want to schedule or we want to process in parallel. So at the end, if kernels perform well, you maybe can get some overhead by overlapping different computational tasks, or maybe computations with data movements and so on. And there are different names for that. So in OpenACC, it's called streams. With OpenMP, we say we do data dependency. Distribute our tasks on the GPU, we usually need a certain synchronization so that all tasks finished, and we can be sure that our distributed data will really not change before we may be moving it back to the CPU. So by default, the compiler will handle this synchronization. But you can also change for CCE, you can change this behavior by using this compiler flag -h ACC model, auto sync from none to maybe kernels or all, and then the synchronization is done also on a different level.